A body slides down an inclined plane, which makes an angle of 40 degrees with the horizontal. Neglecting friction, calculate the velocity of the body after sliding 5 meters. B. Calculate the time taken to slide the 5-meter distance. So in this aspect of calculation involves friction, but the question say we should neglect friction. So some of the parameters in friction, we will neglect them. Okay, so now the question only asks us for the velocity which the object sliding. The object is inclined, so if it's sliding, then the gravity will help it to slide. This is the drawing showing the movement. This is the horizontal line, then this body now inclined with 40 degrees. So this is the body that is here initially, but when due to this inclination, acceleration due to gravity, we try to push this thing down, then it will now be sliding coming down. So and the question say we should calculate the velocity which the body uses to slide down. So now it's sliding down like this. Now considering this inclination, we will now use the acceleration. Our acceleration now will be equals to g sine theta, which is going in the same way with the line of inclination horizontally. Okay, going in the same direction with the line inclined. So now we will now consider A to be acceleration due to gravity sine theta concerning the inclination. So using this formula now, one of the motion formula, v squared equals to u squared plus 2as. Yv is the final velocity. That is the final velocity after sliding down 5 meters. What is the velocity which will be the final velocity after 5-meter distance? Then u is the initial velocity. When it was there was no velocity until the gravity begin to act on it and it tries to slide down. Now the initial velocity now be 0, which is the u, be initial velocity. Then our g is the acceleration due to gravity. Then s is the distance which it has traveled to. Now we will replace this our acceleration with this one, considering the inclination. So our new formula will become v squared equals to u squared plus 2s first, 2a, okay, then g sine theta, replacing the a. Now let us begin to fix that. We are looking for this, okay, which will be equals to u. Our u is 0. Our u is what? 0 plus 2 times s, which is 5 when it has moved 5 meters, times g, which is 10 approximately, okay, times 10, then sine theta, which is 40. Now our 0 has gone. We now find the sine theta. Sine theta, we'll find sine theta with our calculator. Then sine theta will give us, sine theta gives us 0.643. Now we now have 2 times 5 times 10 times 0.643. And when we multiply all this, we now have, when we multiply it with our calculator, we now have 64.2, which means v squared is equals to 64.2. Then making the subject of formula, we find the square root of both sides. Square root of both sides. So this sign of square root, you can cancel these two up. We now have only v equals to square root of 64.2. And when we find the square root of 64.2 with our calculator, we now have 8.02 meter per second. Now calculating for the b, calculating for the B says that we should find the time it has taken this sliding to reach 5-meter distance. Okay, so now the formula we will use to find it is V equals to U plus AT. So V is final velocity, U is initial velocity, A is acceleration due to gravity, and T is the time they are asking us to find. Now, fixing our values, we have calculated for V before, which is 8.02 equals to our U is 0, remember, plus our A, which is still G sine theta times T, and 8.02 equals to, this has gone, then our G is 10 approximately times sine 40. Okay, sine 40 is 0.643 times our T. Okay, now when we multiply this, we now have 8.02 equals to 6.43 T. Making T subject of formula, we now have T equals to 8.02 over 6.43, and when we divide, we now have 1.25 seconds. So we now have 1.25 seconds. So please, I beg you to subscribe, okay? And follow me on Facebook, right? Thank you so much for watching.